Diagonal matrices have many interesting and important properties that make them really useful in a variety of linear algebra applications. Now, in this exercise, exercise 11, you are going to explore some of those properties. In particular, what happens when you pre-multiply by a diagonal matrix versus post-multiply by a diagonal matrix. So the coding part of this exercise is actually pretty straightforward. This is more about trying to use this as an opportunity to learn more about matrix multiplication and diagonal matrices. Okay, so in particular, what we are going to highlight in the code is these two factoids right here. So pre-multiplying by a diagonal matrix scales the rows, whereas post-multiplying by a diagonal matrix scales the columns. Okay, and yeah, here I just say we're going to use it many times or several times throughout the rest of the book. So here's how we are going to explore this. So a matrix of all ones, 4 by 4, we'll create a matrix of all ones. So 4 by 4 matrix where every element is equal to 1. A diagonal matrix where the diagonal elements are basically 1 through 4 squared. So 1, 4, 9, and 16. And then a diagonal matrix equal to, okay, maybe I explained this in a slightly weird way, but the square root of the previous diagonal matrix. I think in hindsight, maybe I could have said that the diagonal elements should be 1, 2, 3, 4, and then a second matrix where it's that squared. Anyway, doesn't matter. Let's see. And now here is the important point. So when we pre-multiply by the diagonal matrix, so we are pre-multiplying the diagonal matrix by the ones matrix. There you can see we are modulating the rows of the matrix. So we start with a matrix of all ones, and we pre-multiply by this diagonal matrix that has these numbers on the diagonal. So pre-multiply, the columns don't really change. It's the rows that are being affected. And when we post-multiply, we see the opposite. So now the columns are changing. It's really bad formatting, but the matrix is split across 2 pages. It's something that can happen with publishers. Anyway, you can see the columns are being modulated by the diagonal. So very different behaviors depending on whether the diagonal matrix is to the left or to the right of the matrix that we are multiplying. Okay, and then finally, we want to pre and post multiply by the square root of the diagonal matrix, which is the matrix that is just 1, 2, 3, 4 on the diagonal instead of 1, 4, 9, 16. And that is quite interesting. That gives us this matrix. You can see it's like a combination of modulating the rows and modulating the columns. And in fact, what's neat about this matrix is that it ends up being a multiplications table, a times table. So yeah, this element here is 2 times 2. Here we have 2 times 3 is 6. And, 3 times 4 is 12, and so on. Okay, so now I will switch to Python. I'll show you the code solution for this exercise. As I mentioned, the Python code for this exercise is not terribly difficult. Here I have soft coded n equals 4, and that's to give you the opportunity to explore larger matrices if you like. Okay, so here I call these the base matrices. This is our matrix of ones. Here we have our diagonal matrix of the numbers 1 through 4, and then squared. And then we have the square root of that. And again, you could also have constructed this to be a diagonal matrix with the numbers 1 through 4 on the diagonal, and then square that matrix instead of taking the square root. Okay, so then, yeah, the code is pretty straightforward. Here's the matrix I call pre. So the diagonal times the ones matrix, and then post is the ones matrix times the diagonal. And then we have both, that's SOS. So we have the square root of that matrix pre-multiplying and post-multiplying exactly the same matrix before and after we call this like a target matrix. This is a fairly common approach that you will see come up in linear algebra, advanced linear algebra topics like eigendecomposition and singular value decomposition. This sort of thing comes up pretty often, including operations like this, where you pre-multiply by a matrix and post-multiply by the transpose of that matrix. And now, because this is a diagonal matrix, this is the same thing as this, right? All diagonal matrices are symmetric. Okay, anyway, here we are just going to print out all of these matrices. Here's the ones matrix, the diagonal matrix, the square root of that diagonal matrix. And these are the three matrices that I already showed in the PDF of the book.